All right, boys and girls, this is the answers to 5-3b. First problem, if the area of this, find the area. So I'm going to find the area. I know area of a circle is pi r squared. So the first thing I'm going to do is write down the formula. And I know the circumference is 48. Well, if circumference is 48, I'm going to know that pi times d equals 48. Well, in order to know what the area is, all I got to find is the radius. Well, if you solve this for d, you'll be able to figure out the radius. The way that you're going to solve this for d is you divide by pi on both sides. And if you divide it by pi, you're going to get the diameter is 48 over pi. And I told you in class that you can leave it like that. That's the exact answer. So if you multiply by 1/2 or divide by 2, you're going to end up with eventually 48 times 1, pi times 2. So 48 over 2 pi, which can reduce to 24 over pi. So this stands for the radius. Now I'm going to plug that radius in. And remember, we have to square this entire radius. So you get 24 squared and pi squared. So 24 squared is 576. And pi squared is just pi squared. And you're going to have to multiply this times pi. Well, when you multiply by pi, you just end up 576 times pi is 576 pi. And then 1 times pi squared is pi squared. Well, here you're going to cancel some out. If there's 1 pi at the top and 2 pi's at the bottom, you learned last year when you divide these, you're going to end up canceling the 1 out on the top, and you're going to be left with 576 over pi. And this stands for the exact area in obviously units squared. And if you wanted to find out what the rounded answer was, you just have to do 576 divided by pi. Next one. Here, we're going to skip right triangle because you have yet to learn the Pythagorean theorem, although some of you may already know it. But I'll go through this one in class. What you're most concerned with is knowing that a rectangle and a square, since a square is a rectangle, the maximum area is going to come from the square. And if you have a perimeter of 60, when I divide 60 by 4, I can figure out that I can get a perimeter of 60 by making all the sides 15. And if all the sides are 15 and I multiply base times height, I get an area of 225. That's going to give us the largest area between the rectangle and square. The circle, if the perimeter is 60, that means the circumference is 60. So we're going to do exactly what we did before. We're going to find out what the diameter would have to be. And in order for the perimeter to be 60, we would know that if I solve for the diameter, you get 60 divided by pi. And if I cut that in half, you get 30 over pi, which is the radius. So if I use this radius, in my area formula, pi r squared, I end up getting, you square the 30, you square the pi, you end up, when you simplify this down, you end up just like in the last problem, we would simplify it down to 900 over pi. And when you do 900 divided by pi, the reason why I'm going to find the exact area, because I want to compare it to the 225, you end up with about 286.5. That's going to show you now that even with all quadrilaterals, a square will yield you the most maximum area, but a circle will get you using the same amount of fencing, a circle is going to get you actually even more room inside, which is a lot of times why when you think of stadiums, when you think of pools, a lot of times you'll see that the outside of the pool, there'll be a circular fence because that'll use the least amount of fencing for the maximum amount of area. The next one, parallelogram has an area, so right away I'm going to say base times height equals 30. The altitude of BG equals 4. Now it tells us that BG is the altitude, so this is 4. And the parallelogram ABCD, so this whole parallelogram has an area of 30. So let's find BC. BC would be a base of the parallelogram. So if you know that the area ABCD is 30, and you know that this is 4, you can say 4 times what base is going to get you 30. And if you find that, you're going to find out that that this side right here is going to be 30 divided by 4, which is 7.5. So now I know that this right here is 7.5. All right, so that's the last one. Here, this is the next question. George used 450 feet of fencing to a circular pool. Well, that means that the circumference of that pool is 450. So I don't know if I'm going to need it, but I know pi times d has to equal 450. He wants to leave a 3-foot walkway around the first fence. So let's think about this. Let's draw a picture. Here's the pool. He wants to leave a 3-foot walkway around the first fence. So here's going to be a 3-foot walkway, and then you're going to have a fence. So this represents the first fence. Then you have a little bit of a walkway, which is 3 feet, and then you have the second fence. And we want to know how much foot of fence is. So we need the circumference of the second fence, which we still need pi times diameter. Well, if you want to know pi times diameter, then we know it's from 3 to 3 here. We also know on this side there's going to be 3 feet of fencing. But what we want to know is then how much is the diameter of the original circle. So to know how much the diameter of the original circle is, I'm just going to have to solve this right here for d. And if you divide both sides by pi, you get the diameter of the original circle is 450 over pi. Well, that means from here to here is 450 over pi. Well, don't forget about this 3 and this 3. So the new diameter of the fence we want to find out is pi times, and the diameter is going to be 450 over pi, but then we have to add the 6 extra feet, which was the walkway. Well, now let's just go ahead and solve this right here. So let's distribute the pi. So you get 450 pi over pi plus 6 times pi is 6 pi. Well, let's simplify this a little bit. Those pi's cancel out, and I'm left with an exact answer of 450 plus 6 pi units. And that's how you're going to get that one. If you want to know an exact answer, then you're just going to have to just do on your calculator 450 plus 6 pi. All right, so here is the next question. You're going to notice that as soon as I read the round school track is 0.25 miles long, I drew a ridiculously bad circle. But let's pretend that when you think of a track, you know that it has, this is like the inside, and this is where you run, right around here. And it says the inner edge. That means if you're running right along the inner edge, right around here, it's going to be 0.25 miles long. That means the circumference of this like smaller circle right here, because that's if you run around it, is 0.25 miles long. Okay. The next thing you know is the track itself is 6 feet wide. So from there to there is 6 feet, and obviously down here it's going to be another 6 feet. And then it says how much farther does the person that would be running on the outside run than the person on the inside. So we need to we already know the distance this person runs. The issue that we're having is that this is in miles, and we need it to be in feet. Well, 5,280 feet are in 1 mile. Okay? So if I want to know how many feet this is, I'm going to multiply 0.25 times 5,280. And you get that it's 1,320 feet. The reason I did that is you want to have the same measurements within a problem. So here I know that of the inner circle, the circumference equals pi times diameter, and I now know that the circumference is 1,320 feet, which equals pi times diameter. Well, I need to know what this diameter is in order to know what the diameter of the big circle is. So I'm going to divide by divide by pi, and now you know that the diameter of the small circle is that. Well, now I can figure out the diameter of the bigger circle, because the diameter of the bigger circle is the smaller circle's diameter plus 6 and plus 6, or in other words, plus 12. So if I want to know the circumference of how far around it is of the outer circle, I'm going to use the diameter of the outer circle times pi. Because remember, circumference is the diameter pi. Well, let's go figure out what this equals. And again, the reason why you wanted this in feet, because you're going to add 12 feet. You don't want to add 12 feet to some amount of miles. So we're going to distribute the pi, because the pi is, you can see that's this times this, and you end up with 1,320 pi divided by pi, so those are going to cancel out, plus 12 pi. Well, the circumference then is equal to 1,320 plus 12 pi. That's the circumference of the outer circle. So let's go back. The inner circle circumference was 1,320. The outer circle was 1,320 plus 12 pi. So what's the difference? Well, if you take this one, the bigger one, and subtract the smaller one, well, you're left with 12 pi. So the person runs this much longer, 12 pi, than the person that runs on the inside. And 12 times pi, if I wanted to get a rounded answer, the person runs about 37.7 more feet. Here's the next one. Find the shaded area. So the area here is going to be the whole circle minus this small part we're taking out. So the whole circle is, we're going to assume that this 14 was for the whole thing. If you thought it was just for this one, you're going to get a different answer. But I'm assuming that this 14, because it doesn't specify, is for the whole line. So you have the diameter of the shaded area would be pi r squared. So 14 squared times pi, minus the small circle, which is 6 squared times pi, or 36 pi. 14 squared is 196 pi minus 36 pi. So I'm going to go ahead and leave the answer in exact form. And 196 minus 36 is 166 pi. This is the area of the shaded unit squared, obviously. And if you wanted to know the exact answer, you would just have to multiply. Here, to find the shaded area, I'm going to find the area of the triangle. So if this whole thing's 11 and this is 8, that would make that 3. If this is 8, that means the height of the triangle is 8. So the triangle is 3 times 8 divided by 2, which is 12. Then to find this area right here, I'm going to find the area of the square, which is 64, and subtract the area of the circle. So if it's 8 all the way across, we need to know the radius, which is 4. So 4 squared is 16 pi. This is the area of the circle. This is the area of the whole square. So if I take out the circle, this would represent the area of the shaded region. I can't subtract them because one of them has a pi in there. And then I'm going to go ahead and add the 12. So 64 minus 64 pi plus 12, I can combine the 64 and the 12 and get 76 minus 6 pi would be the total shaded area. Last one is a half of a circle. So to find the whole circle, you would do the radius, which is 6, squared, 36, pi. But then I'm going to have to cut that in half. So you get 18 pi as your final answer, units squared. Final one, find the circumference. Circumference equals pi times diameter of a circle inscribed in a square. So let's draw that. It's a square. You have a circle inscribed in a square, which means inside a square. The perimeter, find the circumference of a circle inscribed in a square whose perimeter is 16. So if the perimeter of the square is 16, that means all the sides are 4. So if all the sides are 4, that means that the diameter of that circle is going to be 4. So if it's 4, remember, we're going to just pi times 4. That's the circumference of the circle, 4 pi. And if you want to know what the exact answer is, you can just do 4 times pi. And that is the homework.